My name is Ali Nezhad. I'm Head of Sustainability and Innovation for Boral. When you look at concrete performance, there are short-term and physical requirements for concrete to meet, including you need to design concrete to meet the strength requirements, to be able to tolerate the loads that's being imposed on it. But you also need to make sure that the concrete can continue to do that over a long time. And that's a very important concept, not only from performance point of view, but also from sustainability point of view. So when you look at concrete, specifically larger concrete elements, one key issue that relates to durability in terms of long-term performance is the cracking that could happen as a result of the heat that's generated in concrete. The first durability issue is a durability issue known as delayed ettringite formation, which could occur months or years after concrete has been placed, and that would lead to extensive cracking in concrete. And with that would come impacts on the service life and so on. The other durability issue that's associated with that is when you look at this significant temperature rise in concrete, there would be a significant difference in temperature between the hotter interior of concrete and the cooler exterior of concrete, which is exposed to the ambient condition. And this temperature difference would lead to so-called differential cracking, which is known as early-age thermal cracking of concrete. Within days after pouring the concrete, the temperature could start increasing significantly if you're dealing with a large concrete element, and that's where the problem starts. Evolve is an advanced modeling tool designed to predict the temperature development and temperature differential in concrete. And that's based on more than 5 years of R&D in collaboration with the University of New South Wales, where we've developed very specific empirical and mathematical models that are suitable for Australian and specifically Boral concrete. Evolve uses those empirical models and the project-specific information, including specific information about the mix design itself and the project conditions, which include the geometry of the element, the surrounding conditions and boundary condition of the element, environmental conditions including exposure to sun, wind speed, ambient temperature, the type of formwork that's being used, and uses all of that to come up with a reliable estimate of temperature and temperature distribution in concrete. Evolve can be used as a reliable risk mitigation analysis model. What it does is it helps you to assess the effectiveness of various risk mitigation measures to reduce this risk, from the cheapest and the least complicated all the way to more expensive and more complicated measures. The key strength of the modeling tool is that it can be used in the design stage to prevent all the extensive measures that needs to be reworking or rectifying the challenges that come with the delayed ettringite formation or early-age thermal cracking of concrete. With the mixed proportion and type of material known for concrete and the project-specific information known for the project, the modeling tool will be predicting the risk associated with the delayed ettringite formation and early-age thermal cracking, and this gives you the opportunity to start looking at mitigation strategies before the placement of concrete. The tool basically is one of the key advantages that engineers and designers would have in terms of predicting some of those impacts on the service life and making sure the design service life is not impacted. The worst nightmare for an engineer would be to dealing with situations that he or she can't predict and the impact on the material or structure that he or she can't really understand or predict or take measures to avoid them. If I don't know this concrete is going to crack, if I don't know the temperature is going to exceed the required limits, I'm going to take very extensive measures to reduce the risk. And that's obviously something that's not accepted in engineering as well. The alternative would be to use a tool that's reliable to give you the information that you need in terms of understanding the actual risk of this and finding an effective and low-cost measure to address this. And that's what Evolve does for engineers.